Hi, and welcome to my next instance of my little mini series that I inadvertently stumbled into, where I tried to create uh, mini games or mini applications in as little code as possible, always in Elm, so far at least. Yeah, it all started with this Minesweeper clone I did a few weeks back, and last week I did a touch typing trainer. And somebody came up with a really interesting idea to do a jig puzzle canvas game. And so I actually think this week might be my last time or the last instance for the series, because I have to step up in my role as a stay-home dad next week. So I'm not sure I'll have this time slot available next week to do the same thingy. And that's why I think actually it's a nice opportunity, because I do think it's actually quite a challenging target to do this in these 2 hours, 2.5 hours time frame that I set myself, and the 100 lines of code. But nonetheless, I will give it a try. So to create something like this, where you can drag puzzle pieces around, so yeah, I'll give that a shot, and I don't want to lose too much time with the introduction. So I think I'll start right away. The YouTube user here, James Bond JWJW00007, said like, yeah, creating a jigsaw puzzle canvas game, but I think actually I can do one better and do it without canvas at all. So my goal basically is to use an SVG. SVG has a super interesting feature. SVG called clip path. Exactly. And with this clip path, basically you can define a path, and that cuts out a piece on a different SVG element. So basically what I want to do is have the image, whatever it is. I have the cat image, obviously, and I just want to duplicate this for every puzzle piece, but just cut out the section of the image that is responsible for this puzzle piece. Because what this allows us to do is SVG path, use the path element. That's not what I want. Also, that's exactly what I said. It's this thing, because we can do nice curvy things like this heart, for example. So I'm pretty sure we can do the classic puzzle piece geometry with this, without having to like imperatively draw around on the canvas or anything like this. Yeah, without further ado, let's create a new Tmux session first, then a new folder, call this puzzle. We go in here, puzzle, and we call Elm init, of course. Yes, so now we have just our source folder and the Elm JSON, and as I said, I have prepared a cat picture. Downloads cat.png. So if we open that, boom, that's going to be our picture. I'm going to stay also with a square here, because that just makes a lot of calculations a lot simpler. And today I'm actually going to work with Elm Reactor, which is the inbuilt development server. Let's do a Firefox here. I prefer that one for development. And go to localhost 8000. And that's what it looked like. And we don't have any Elm file yet. That's where we cannot do a lot here just yet. Dependencies, oh yeah, that's nice. And so that cannot be used for hosting an Elm application live. If you're interested in that, there's a section in the Elm guide and I demonstrated that a few weeks back. I'll link it up here, how to build an Elm application from scratch and host it on GitHub Pages and deploy it automatically if you push to Git. So, but just in favor of not repeating myself and saving a bit of time, I will not use this today. Puzzle. So yeah, let's create that source main Elm as our entry point. And we go to a quick sample. As always, I like to start off from something that everybody has access to, like the Elm example application, module main, exactly, exposing main. So now if we go into the source folder, we see it's here, and we have this counter app. So the counter app in Elm has 25 lines of code. And like, I'm not super optimistic I will manage to do the puzzle application in just 75 lines more, but I will give my best at the end to just squeeze a few lines out without sacrificing too much readability. So I'm just going to say, see how far I can take it. Yeah, so as I said, I think I'm going to start out with drawing the characteristic Jigsaw puzzle edge, because that's, or actually maybe draw an SVG to start with. That's a good start. So I have to add a dependency, and while I think on my teaser I said I'm not using any third-party dependencies, I still have to install the SVG package, which is just there to give you access to the elements and the DOM elements of SVG and the child elements itself. So I'm not really counting that as a third-party dependency. So now we have that installed, and we can do import SVG. Sure, exposing SVG. I also will continue to use my Copilot or Codium integration here to just save me from some typing, since it's going to be time critical today, I think, with all that I set out to do. But for now, I'm going to disable the diagnostics because I'm lazy and like in favor of not wasting any lines. I will probably skip a lot of type annotations, and I don't want to get nudged about the missing type annotations all the time. All right, we have imported the SVG package, so let's draw an SVG package. I'm just going to throw away most of the example app here, SVG, exactly. We're importing that from the SVG package. We want a view box attribute, exactly. View box, and let's go from sure. That's also a nice span. So that basically defines our viewport, what part of an SVG in the SVG coordinate space is visible. And so let's load our SVG image. The source of an SVG image is referenced with href and not with source like in HTML. So let's say cat.png, and we say width from SVG is also 100. So I think there's one bracket too many. Let's see, reload. Going to open the inspector here right away and zoom in a bit more. And with the nice thing about Elm Reactor is that we get these nice Elm error messages directly in the browser window. This arguments, so I caught this in the wrong way. Image, yeah, there's the children, the empty children for the image I'm missing. And here we have it, a nice cat picture. All right. But for now, I don't want the cat picture. I want to draw the edge of of a puzzle piece. So let's start with something easy, a horizontal edge. And so this is defined by a start and an endpoint, obviously. If we go to the MDN SVG path, then we can see here the way we want to do a path is like you have the path element and then you have this mysterious D attribute. So if we go to the D attribute, then we see again the same example with a heart, but there's actually a lot more options. Like there's these different commands to draw lines. So to draw a line, the first thing always is to go to a certain location in the picture, and then you tell SVG how to continue drawing from where you went. So M is always move like the starting point to somewhere, and then we have a few ways to draw lines. I think the upper, I don't know if there's a difference between the upper and the lowercase version, but if we look at H, yeah, okay, we see this. So H is draw a horizontal line from the current point, which is exactly what we want. So before I draw it, I want to store this information somewhere. So I want to say it's an H edge and it starts at 0, 0, something like this. And the endpoint is, we just have to specify the X coordinate. So let's say the length is, well, we're at 100 and 100. So let's say we want to do 4 puzzle pieces in one row. Let's say we go to 25. So this is obviously not known, this H edge constructor. So we create a new type and we call it H edge. Yeah, V edge will come in a bit. And I think we're going to work a lot with like 2-dimensional vectors. So I'm just going to introduce a type for that as well. And it's just going to be an alias for exactly a record type, but we're going to work with floats. So now I can construct a record with just like assigning X and Y, or I can also just declare exactly a little helper function. And this way I can just write vec. Awesome. So now I have one horizontal edge here, and now I want to draw that. So maybe we create a function view edge that takes an edge. Yeah, let's just write this out. This is start, this is end, and then we want to paint a path exactly, 2 arrays, one for the attributes, one for the children, no children obviously, and then I want the D attributes, but I find it always disturbing to have like all the single identifiers taken by library exposed library functions. So I'm just going to alias SVG attributes where the D attribute comes from to SA, and this way I can write SA.D, and then I can actually create a local expression called D, and that's what I'm going to assemble now. So now I want to have something like M and then the coordinates of start, so I can deconstruct them right away here into X and Y. And now I want to move to this X and Y, so I'm going to, whoops. I have to concatenate, yeah, exactly what the Codium is proposing here, but it's very verbose. So I'm going to, since I'm going to be using printing or converting these vecs into strings a lot, I think I'm going to right away write a little helper function here. Let's show is fine by me, x, y, and we're just going to say from float. That's the function to convert a float to a string. Nothing fancy here. X, then we're concatenating that with a space and then add our y, and this way I can just write this show, but we want the h command and show. Actually we can just go back to calling the start, and then we can remove all of this. So maybe we give it a stroke red and sa dot fill. Fill is actually long enough to say none, and stroke as well. I'm not going to have a top level expression called stroke. Did I import it? Maybe no. Stroke. How are we doing? Age needs 0 arguments. Aha, okay. That is correct. HS should take a vector and a float. That's correct. From float is not imported. Will the LSP help me this time? Yes. Import from string. Refresh. Show end is show end is just a float, so we don't call show, but just from float exactly. And now's the question, why is there no path? Because I never called view edge, so I'm just calling view edge edge. And now you see there maybe in the very top a red line from 0 to 25. Awesome. All right. So now we do the same thing for the horizontal edge. So let us, where's the definition? I'm just going to duplicate the horizontal edge, call this v edge, and create. Let's see. I'm pretty sure Codium has a good guess on this. Exactly. La la la. And view edge. And now here for view edge, let's see what this pattern does not cover all possibilities. That is correct. So because now when we call view edge, this could also be a vertical edge, of course. So we have to write a little case expression. So let's change this to edge and then do case edge of, if it's this guy, then we do what we did before and we remove the unnecessary braces. And if it's a V edge, exactly, we just replace the H through a V here. Yeah, wonderful. So does this compile? It does. And now if we change H edge here for V edge, then we have a vertical edge. Wonderful. Okay, so those were the easy cases, obviously. The next thing is going to be the squiggly jigsaw edge. And so for this, I have to revisit the Q section here, the cubic Bezier curve or quadratic Bezier curve. And so I have found some awesome SVG resources, this SVG path visualizer. And here we can look at all how the different path commands basically act out, where these coordinates for these points that we specify are. So that's going to definitely become one of my go-to resources whenever I have to try to draw SVG paths. So I think what I'm going to use is the good old Bezier curve here. We have our starting point, and then we have the C command, and then we have 3 more pairs of coordinates. And so the first one, or the first and the second one, are what's called control points. So those are points that are not on the curve that we're drawing itself, but have a big influence on like how the curve is shaped basically. And so to play around with how to actually draw this, I found another interesting resource, which is this, not this one, no, the SVG path editor. And I've already prepared a shape here that looks very much not like a puzzle piece. And what this is basically is just a chain of points. And by using the L command, I'm connecting them all into one loop. So it's one. Can I actually highlight? Yes. So if I go here into the list of commands, then you see we're starting on the left top here, and then we move our way to the center, and then we go all around this to form kind of the top edge of a puzzle piece. And now the magic comes in when I change out these commands for quadratic Bezier curves, or is it cubic? I don't know. For the C commands. And now we have something that looks a lot more like the shape of a puzzle piece. So this is what I want to do next. Yeah, that's without further ado. And how do we call this? Edge jigsaw edge. So the horizontal jigsaw edge. And we're going to invent a new constructor here. Exactly, edge jigsaw edge. And so what are we giving that? Maybe a starting point as well, and then a list of vecs. I have to put brackets around here so that it knows in which order to apply the type arguments. And so yeah, let's just start with edge jigsaw edge. That looks great. And let's just call this points. And now we're just going to basically, I'm just going to copy this out here. Copy, insert points equals, and then we're just going to start writing an array. So this is going to be a vec, and then it's always 2 coordinates form 1 vector. So this is another one. This is another one. This is another one. Oh yeah, we have leading commas in Elm usually, so vec, and another one, and then here we also have a vec. And then we have the closing bracket, fix the indentation a bit. So does this compile actually? No, vec function expects 2 arguments. I missed it. Because here I'm still missing the remaining vec calls. third element does not match. Why not? Because he has one too many. Alright, and now it already complains about the fact that it doesn't know how to draw this kind of edge. So let's fix that also right away, and maybe just as an intermediate step, we just draw lines, straight lines between the points. Let's start again with M, and then the rest is horribly wrong. I mean, we do want to concatenate with something, and it's probably... I think we can just write one C command, and then we just list map show points. Really curious where this gets us. I see a string on the left and a list on the right. That is correct. So we also have to join these. Join with space. And then we use this pipe operator to just say like, oh, everything that comes after this little arrow thingy is, we can also just put it in parentheses like this. But I find this pipe operator a bit more readable. So does this compile? Join is not known. String, let's import join. I don't know why the LSP didn't want to give it to me. Alright, it compiles. Let's bring this back into one line. And now we say instead of VH, H, Jigsaw, Hedge. Let's rename this. Jigsaw Edge. Refresh. And this looks very small because all the coordinates here are between 0 and 1. So basically I want to scale this up to the size of our puzzle piece. And maybe I try to define some consts here, my configuration. I'm just going to call this CFG. And let's say tile size is 25. Good guess. Good guess. And then basically what we want to do is we want to multiply all those points with 25 with our tile size. So what I can do here is list.map. Let's call it times the function, and this is good as well. And let's create a times function which takes an n and a vec, and we can deconstruct this directly into x and y and create a new vector with both components multiplied. So that's wonderful. Let's refresh, and there's a syntax error. I'm missing a closing bracket here, and this is exactly why I prefer the pipe operator. That looks very nice already. So what we can do, we can replace this like so, and it still works. Awesome. That's very neat. And now, of course, we don't want to just have one puzzle piece. So I'm wondering if I introduce like the notion of rows and columns now for these edges, or yeah, I think I do that, because basically if I get the first edge for the first row and the first column, the top edge should be a horizontal, a straight edge. So basically what I want to say is we give this here col and row, and say if row is 0, then give the thing that we had before, and else we want to give a age jigsaw edge. And this also should take col and row, since there are several ones, of course. And so we have to add these arguments here. So basically now we should get an error because we're not calling this function with any coordinates yet. So let's change this. Again with the pipe operator here. So let's say 0, 0. So this should give us a straight top edge. It doesn't, which is a bit annoying. Why? Because I'm still calling jigsaw edge directly. This should be edge. And now we have a straight edge. And now if we want to have the second one here for row 1, this should give us the jigsaw edge, which is great, but the position is not great. We want the position to be on the bottom of that puzzle piece, of course. So let's go back here. Yeah, let's go into jigsaw edge, go to definition. And so not only have we to multiply this, but we also have to change the starting point to begin with. So yeah, both of those basically, let's call this origin. Is, yes, wonderful. We just multiply col and row with the tile size. Now, unfortunately, those are ints, so we want to convert them to floats so that we can multiply them with a float. Everything is explicit in Elm, which takes some getting used to it if you're programming in languages where this is like auto boxed converted or whatever. But I prefer giving these extra 7 letters to be explicit over the errors that you get in large applications where this happens automatically. So now we have a new origin. We can replace this by origin. But we also have to move all our other points here. So not only do we have to list map, we also have to add basically the origin to all those other points. So after we've sized them, we basically want to say list.map add origin. Maybe like this. And we don't have an add function yet, but that's another simple v0, v1 function that probably Codium knows already how to do. No, it does not. This would be v0.x. That looks more like it. Boom, and now it's in the correct position. So if we go one more to the right, then I'm curious what happens. Oh, it looks good. And if we go back into the first row, then it's still wrong. So let's fix that. Here, basically, we also want to have origin. So let's call origin, call row, and let's just extract this origin to be a top level function that takes col and row, and then we give it the arguments here and here. And yes, I know I'm calculating the same value now twice, but the performance is the least of my worries currently. And now we save and we reload, and now it's entirely vanished. That's weird. Path, go to x24, and then that looks all good. Why do I not see this? If I go to -10, is it? Actually, I'm not sure. Do I have to have commas between the coordinates? I think so. I think my show function is wrong. I think it has to look like this. Or not. M25x, 0 is y, and then a horizontal line to 25. Ah, yeah, so that's actually wrong as well, because I forgot the second step, which is moving this target position by the origin as well. That's not the right function here. So what I want to do is... How do I do this? Ah, yeah, I know. I want to say we take again the origin, and then we say column. Oh no, then we just add the tile size basically. So we can just say col row and then .x. I'm not sure if that works. I'm very curious. And then we just, yes, add tile size. Does this work? It does. And maybe the comma was wrong after all. Why is it still not visible? Move to 25. Ah, I have to scroll up. There's the line. Perfect. So now is it with spaces, with commas? Yeah, it's with commas. Okay. All right. I just was scrolled down. So this looks good. This looks good. Now let's do the same thing for the vertical edge, because that's the exact same problem. Going to replace this. And now it's just the y coordinate, and of course it's v jigsaw edge now, and this is also a v edge, and of course we need call and row arguments for this function, and this function doesn't exist yet, of course. But we can just pretend. Let's just say v exactly, and we just write debug.todo. This way it will compile anyway, and it's only when we actually call this function that it will crash, and Elm of course doesn't let us compile this application in production mode while we still have these debug expressions in here. But let's see how it looks for the outer edges first. V edge for 0, 0. So now I'm expecting a horizontal edge on the left. Perfect. And now I can actually demonstrate it. We go one to the right, and now we should see also a very, yeah, I know. So that was actually a good test, because here also we have to test whether the column is 0, of course, and not the row. And now we have this error that we hit our to do. And so I basically have to do the same thing and just turn it. And so I'm wondering, I think I will just export this to, or like move this to be a top level function, and then I will just transpose those. Those are what? Bezier points. Let's call them Bezier points. And then we can just call them here Bezier points. And now in our vertical function, we're going to compute a bit around probably. We want to points basically, or actually I don't think we even need this. We want to do nearly the same, but before we use the Bezier points, we want to transpose them. So transposing in linear algebra means we are switching out the x and the y component for at least for this two-dimensional case. List.map transpose. And the nice thing is, if you know the mathematical terms, is that there is a lot of software, of course, on the internet that uses these correct terms already. So the LLMs that were trained on this are very good of inferring what you probably mean. And again, here, Codium is exactly right on what I want. So now if we refresh, whoosh, we have a nice horizontal edge. All right. So I said we have 4 rows, and we took care about having the straight edges on the top and on the left. And of course we have to do things on the bottom, the same thing, the detection on the bottom and the right as well. So that means, where's our little test? If row is 0 or row, let's call this the resolution of the puzzle. Let's go to CFG and add a res expression here with value 4. And we want to do this the same for, in the same way for the vertical edge. So that means if I call vertical edge whatever 4, then I should get a straight edge here at the outside of our puzzle. Wonderful. And if same for horizontal edge on the bottom, I don't know why I cannot see it. Maybe I make our view box a bit larger. I'm always afraid that it's just outside. And then we say width, I guess it's the SVG attribute, or let's say height 100%. There's a trailing comma. Bam, refresh, height is not known. Why is it not imported? Bam. All right, there's our border exactly. So that's nice. So we can basically draw the edge of every puzzle piece, like the edge of between two puzzle pieces is always kind of like shared. Of course, they have their own, each puzzle piece has their own edge, but the shape is the same. So, like, to be precise, what I call just edges now are actually the shapes of edges, but it's all good. So basically we can draw a whole piece now. So let's just, for fun of it, or let's call it view tile, call row, and we'll just do a SVG, a group. And in this group, we are going to put the 4 edges. So we have V edge. Exactly, we have, then let's go clockwise, edge, no, I want to start on at the top, and then I want to have the edge of column +1, exactly, and then we have another horizontal. The bottom edge is row +1 +1, and then we have another vertical edge where again we have col row. So does this compile? It does not. G is not what I expect. Why? What is it? List of attributes and a list of, yeah, okay. of course I have to say view. Oh, we can just map this. All of those edges, we want to say list map exactly view edge. Refresh. It's not happy. Let's flip this around. Boom. Let's format. All right, and now we can call view tile. And we can, let's start on the top left. That looks weird. Because my view box is still off. I want to start at -10, so that we have everything in the screen. All right, a beautiful top left. So if we go one to the right, wonderful. If we go to 3, that should be the bottom right. Then we have, all right. This is taking shape, literally. Good. So we have the ability to create the edges, the 4 separate edges. But as you can see, let's go back to 0, 0. If I just zoom in here, that the fact that we are drawing like separate paths makes these ugly edges, and like not only do we not want to have red lines showing our piece, but we want to use the clip path to cut out the piece from our image. So we actually need one path that contains all those points. So we basically have to join the edges into a single path. I think that's what I'm going to look into next. So yes, so basically I can grab these 4 edges and I'm just going to say make tile, and of course I want to have column and my row here, and I'm just going to dump my 4 edges here, and then I want to return something. So basically I want to have something that has a start point, origin, that's really good. Origin, col, and row, that's definitely good. And then I basically add these segments here that I created. I want to list them all. Some of them might be straight lines, some of them might be the jigsaw lines. So let's just call them segments equals segments. I don't know yet what to fill this with, but let's just say I want to make an assignment here, and then I want to do something with these 4. Yeah, I'm just going to assign them to dedicated expressions now here. Let's call this is our top. This is our right. This is our bottom. And this is our left. What did I do? I deleted too much. So, okay, let's just bring this to compile again. Does this compile like this? It does. Okay, great. So now I can think about how I turn these elements into a segment. So let's just add the top segment first. And because segments like this edge, as I said, like this can be one of these 3 cases that we see here on the top, basically. So one of these 3 cases, so we definitely need a case statement. So I'm just going to start with that and then see where this takes me. So basically, let's say case top off. Wonderful. Let's just have this empty expressions. And since I have already my start, I don't need my start from my top edge, basically. I'm just going to ignore this. Although I need the y component. So let's just say this is x, y. And then we have y, let's call it y underscore. So now what is a segment? So the segment has basically similar characteristics as the edges. It's going to be an H segment, but I don't need to store the origin because we're going to do a loops anyway for each of these. Currently each point is stored twice at the end of one edge and at the beginning of the other one, but if we do a continuous path, we can always throw away the first one. So I don't want these to occur in my segments as neither. And so for any H segment, I'm just assuming that I have already started where I need to start. So here I just need to store the target location. So we don't need the y of the start location. We just want vec x y underscore. And then on the vertical edge, it's basically the other way around. We just want the y, and then we get the y underscore, and then of course this is actually an x here. Yeah, and this I want the y because that stays the same, and here it's the other way around. So here it's a v seg bam exactly. And now I need a new type. Let's call it segment type segment, and it can be exactly either that or a jigsaw segment. And here the syntax will be the same no matter if it's vertical or horizontal. It's just C points in the SVG speak. So it's a list of vecs. So I don't know, this is the most complicated part, of course, and I'm going to just dodge it by initializing it with an empty array for us to start with. Does it compile? It does not compile. Because this is, yeah, actually we can just call them x and y. No need for underscores at all. Does this compile? It compiles again. And so now I basically can ask, I get a tile that is always the top edge. I'm not using the others yet. So maybe I do another, actually replace this view tile here with our new function. And now this can be a path. And we can say stroke blue, fill none. And now comes the interesting part, the D, sa.d. And this is the start, and then the segments. Okay, maybe I have to create a little helper function here. Just create a local function, view segment s, case as off. Yes, no. If it's, then we just say, yeah, I saw it's already. Codium knows. Codium, it's not from float. It is show v. No, it is. Oh no, actually, it was right. I don't even need a whole vector here. Actually, I just need x. That's much easier. So I don't need this at all. This neither. Update our constructors. So those are actually just floats. Float, of course. And now we can continue implementing our view segment function. Exactly. And here I just plop in a to do. Bam. Does it compile? It does not compile because I have to actually create a D value, a proper one. So D is, so let's create start a tile here, exactly, and D equals M, yeah, show start, and then that looks all good. Then we concatenate all of this by just mapping over the segments with our partially implemented view segment function. So let's refresh. There's still the D value missing. And now, but map needs the second argument to be a list of segment. What is segments if not segments? Okay, because this is only one segment. This has to be a list of segments, but for now it's only one. What is, yeah, I changed. So this is an X and this is a Y. These are just floats now, not vectors anymore. And there we have it. Wonderful. So now let's continue clockwise and then directly into the harder case with the jigsaw edge. So in the case of the jigsaw edge, actually I think we can do this. We get, whoops, only one segment, but we get 3 segments. No, actually, we always only get one segment for each edge. Exactly. So the jigsaw, basically we have to use our top here, and we can again ignore our starting position since it's already at the end of the previous edge, but we have our points here, points, and now we just say points, I think. So that's great. And then now actually what we want to do is we want to use multiple edges here. So we say segments top and segments, actually I should make the singular because it's always only one segment. Renamed. All right. To do in 149. Wonderful. So here we just say it's a C command, and then as long as we don't change the command, we can just keep concatenating coordinates. So this should be fine. And now we have, if we inspect this, one path with the 2 edges. So now, theoretically, we should just be able to append the bottom, right? Where is this? 139. Bottom. Bottom segment. Whoops. Segment. And now this looks not exactly, and I have already a good idea what's the reason, which is that currently our edges always run from left to right. And so of course, if we try to omit the starting point and just go from where we left off with our bottom edge that runs from left to right, then this is what happens. So basically, before we append these points, we have to invert the edge basically. Yeah, so this is what we want to do. And also there's a bit of repetition going on here, so we can just map over those. But basically what I want to say to the segment function that I'm mapping over these edges is, before you edit, or I want to be able to invert the segment. So basically for each of those, I want to be able to say, like, for top, we don't want to invert. For the right, whoops. For the right, I also don't want to invert. And for the bottom, I do want to invert. And so now in 128 here in our definition, instead of only getting the edge, we also get the information if we have to invert. And we can do some nice pattern matching. We can just collect this tuple into one identifier here, edge invert, case edge invert. So here we have all the cases where we don't want to invert. So I'm just going to put these into the pattern, the falses into the pattern here. False. And here as well. And now I have to, of course, put this in the right position. I already messed this up. Edge here. Bam. Nah. Anytime now. Okay, and here the last one. And now we have to duplicate this, and for the cases where we do want to invert. True. So how do we invert this? So basically that means instead of our edges running from the left to the right, we, depending on our edge case, oh, that's a funny one, like we have to invert this. So let's do this for the horizontal edge first. For the horizontal edge, we're going from the starting point X. We're still not interested in the Y. That should be correct. So we just have to return the X of the starting point actually, and the same one for Y for the horizontal edge. And here the jigsaw edge hedge. I thought I renamed those. Let's rename those. Edge, edge. Ah, that was probably just the vertical one. Ah, and also why is it not complaining about the missing vertical edge? Interesting. Maybe I made it more complicated than it has to be. But basically we have the starting point, and then we have our little loop. That includes also the end point. So we basically have to take our starting point into a count, and we just have to reverse the points, of course. List, reverse the points. Now the last points is at the beginning of our list, which is great, but that's also the end point of the previous edge, so we have to drop one. Drop one. And then we have to prepend, oh, then we have to append our starting point at the end. So this is getting a bit complicated here. So let's write this out a bit more structured, and then let's see. And then what I said, the start point has to go at the end. So let's create an anonymous function here. Those are points, and we're just going to say PS plus start. Really curious if that is correct. Drop and reverse. I also don't want to qualify. Oh, I thought I already had a list import. Import from list and drop. Import from list. Is this not correct? There we go. Nice. So now we just have to add the what's it called? Left true, exactly. I think map I also want to import from list. So this fits nicely into a line. And it doesn't do anything. That is interesting. Ah, yeah, because that's the same. This has to be a V edge. Boom. All right. So now again, let's inspect this. We have one nice stroke. Do I do the clip path thing now, or? Yeah, I think that's what we do. So now we can use a section in our SVG that's called definitions, or defs for short. And that's, I think, where we're going to put all, because these are invisible. We are just going to put them all here, our clip path def, exactly. And then we're going to just list map mk clip path maybe. And over what are we mapping? Let's just say it's tiles. Or tile definitions, because tiles, I might need this as local variable name. I don't want to waste this in my global namespace. Okay, so now I want to create a tile for each tile in my puzzle. So this is going to be a nested loop or a nested map, obviously. So we have a range from 0 to cfg.res -1. And we're going to map a function over this, and this function is getting, yeah, let's say this is the row, and then we're going to do our range from this again. And now we have futile, wonderful, and futile should be a path. That's our clip path thing, basically. Does this compile? No, we are dangling parents. Make clip path. Make clip path. Let's just say like clip path, and this, yeah, view tile returns a tile, I'm assuming. No. Make tile. Yes. Exactly. So now we can say tile. And tile has start and segments, so we can directly deconstruct the segments. Oh no, actually we can we can just say tile defs is directly that, and then we just call view. What did I call it? View tile here. Wonderful. View tile. Yeah, and view tile, now we just turn this path into a clip path. So let's see. Do I still have this here? Clip path. Clip path has to take the ID and then the actual path as a child. So let's say clip path, and we have col and row, and we need to refer to this ID. So we want to create like a DOM ID here. And since we have to refer to that ID again, I'll just call a function here. Clip ID with column and row, exactly. And then we just put the path inside. And then we say clip ID. Call row, la la la, from float. That's probably zip ID, CID. Sure, and this is not a float but an int. This looks good. Does this compile? From int. Import from string, exactly. Refresh, clip path, cannot find. Please import from SVG. Sure. Boom, tile defs. What is it complaining about? Tile defs is a list of list. Ah, yeah, okay, because it's a nested thingy, of course. Let's bring this up into, and then we just concatenate all those. Boom. All right, and we see nothing, which is expected because it's in the tile defs. But we should see by expand here, we have for each tile, we have one clip path with the respective path in there. All right, so now we just have to also render the images and use these, reference these in each of the, you get it, like rows, columns, refer clip path by ID. So let's say images equals, we do again a double nested loop, and instead of view tile we say view image, and view image takes also col and row. And do I still have the image flying around? No, that doesn't matter. Go back where you came from. Image from SVG, yes. Href was this one, and this was cat.png. Width is 100. Height is also 100. And now comes the interesting part. Clip path, but from SVG attributes. Clip path we say clip ID exactly, no children, save, refresh, nothing is to be seen. That's a bit sad. Those are the devs. Because I actually didn't add the images to our view function. So I can just, this is the devs is just a single, and I'm just concatenating that with the images. Boom. All right. So I have no clue if this is good or bad. So I'm just going to take one image list or 5 list, take 5 images. This is not good. I would have expected like a partial puzzle, but let's see. We only take one. Yeah, clip path. I think the syntax is slightly different. It's this URL, clip path, URL, and then ID. Okay, fair enough. View image. Clip path is URL. Blah. Plus. And then plus closing bracket, and closing quote would also be great. And now we have a puzzle piece. That is awesome. So if I take 5, then we have this partial puzzle. So that is pretty neat. So yeah, maybe next thing is that we can actually pick up puzzle pieces. And so I'm planning to have the interaction here. You click once and then you pick up the puzzle piece, you can move it around, and on the next click you drop it to not go too overboard here. And for that, to start with, we have to know where each puzzle piece is. Currently, each puzzle piece is basically in its own origin, like where it's supposed to be. So we have to store the offsets of these pieces somewhere. And currently in from the example here, the model, so the application state of our application is just one single number, an integer. And so now I want to basically change this into something that can hold all the positions. So let's write an init function actually. And let's just say positions is, yeah, it's a range from 0 to cfg.res times cfg.res. And so that's the length of the list of positions. And what do we do with this? No, that's actually a list of numbers ranging from 0 and so forth. And now we have to turn this into just a repetition. I can just call repeat, I think. Repeat takes an int exactly, and we just initialize this with 0, 0. Bam. All right, and now of course we also have to take into account this position. So for our images, I want to make this a function that also takes the positions of the current positions of our images. Positions. And so here we have the positions. And I think now I can basically just positions, iterate over these positions. These positions don't know though. So maybe it's each position should know to which tile it belongs. So then it's not just a repeat after all, but it's a range from 0 to blah blah blah, and then we're mapping, and then we're mapping again over the same range, and then we have col and row, and then we can just say make a record here where you say col equals col, row equals row, and pos is vec 0 0. Positions is this double array? Yes. So. Then we still need one closing bracket here. And we also probably want to, whoops, concatenate those. Concat, bam. I said we don't need the list. This becomes a bit easier here. Yes. So now we have a list of records, and each record knows the row and the column and the position of the tile. So that means images, positions, da 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 da. We can just map over those positions. This actually becomes easier. Map, we don't need to concatenate because it's already one list, and here we have row, col, pos, and view image. Exactly, and we also want to, well, we can actually just map view image. View image. So now we have col, row, pos, and then this actually becomes trivial, so we can just say map view image positions. Then we don't need this function at all. And maybe we treat ourselves to one new line here, because now we also want to say exactly, look at this. We want to translate the picture to the position specified by pos. So this should already work. I mean, there shouldn't be no visible change. 28. What's wrong with you? Range from... This looks good to me. Try adding... Okay, I'm missing a bracket somewhere. Aha, for that one. Okay, I think this should go here then. And now 194, there's one too many here. View image, cannot find a view image variable. Yes, uppercase, woo, and yes, of course. Now I changed the signature of init function, and since the type of the image function that it returns, the application state is update as used by update and view as well. I think I probably forgot. Yes, the update function is, there's a mismatch here. This is currently still the function from the example. So let's go there and just ignore all those messages. We don't need these anyway. Now refresh, and now we have the complete puzzle. I don't know if you can see it, but there's actually like fine lines between the puzzle tiles, so we're on the right track here. Great. So that means if I were to change, how do I change the, where's the init function? How do I change the position of the first or any arbitrary, or maybe we just randomize them. We want to do that anyway. So to have access to random, I have to again add a first or second party. I don't know what's between the first and the third party actually dependency. Install, but you see, because it's from the Elm namespace, it's not a third. That's why it's not a third party. It's out of the platform, I would argue. So now we have access to random, and yeah, it's of course very abstractly constructed library, because random generation is hard. And the way, so what I want to do is just have 4 times 4 random positions. So let's maybe start out from there. Let random offsets. And to get random numbers, there are 2 main ways. One is to call the generate function, and then because a function that returns random values is by definition not pure, and all functions are pure. So to get actual random numbers, basically I have to ask the Elm runtime to give it to me, but then I have to basically give it also a message so that it can send back to me once it has generated these numbers. And I just want to avoid this for now. I just use the step function. So that step function takes a generator, so something that describes how, just from a random float value or whatever it uses under the hood to generate a value of a certain type, and a seed to generate this. So I want to have a list of vecs, I guess, of floats. So I have to write this generator first. So let's call this generator. And so I want it to be a list. So I can use I can assemble this generator from the primitive generators that I have access to. So they have a generator to generate ints, one to generate floats in a given range, and so on and so forth. And they have also one to generate a list, which is ultimately where I want to start out here. Random list, and then basically I want to have 2 floats, so I can use random.pair, and then I want to say I have to give it 2 other generators for each of the positions of the pairs. So I want to have a random float, and I think I'm just going to import random as R, so that I don't have to repeat myself so often here. R dot next dot next dot, and then I want to have a second float, And that's all I need really. So actually I don't need another expression here. I just pump this in here, and then I have to give it a seed. And as long as the seed is the same, the step function will always return the same random numbers, which I'm not super concerned with right now. In the real world example, I would pass from the JavaScript part, I would pass in the current timestamp to use as a seed, and this time every time I start the app I get different random numbers. Our step is r.initial seed 42. Does this compile? That's quite the expression there. No, there's too many or too little parentheses. Let's remove one. Sounds about right. The first argument, okay. Let's revisit. Step takes a generator and a seed and returns our generated value and new seed. We don't care about the new seed. Our list. Here I need to pass in how many of random numbers I want to generate. So I have to do cfg dot tile size times cfg dot tile size. That's one too many. Bam. Refresh. And now at least we have a different error. But pair needs the second argument. Yeah, okay. I cannot just say rfloat. How do we do this? Let's say, like, I have to specify the interval between I want, so I will just say r.float from 0 to, I don't know, 100, like, let's say, oh well, max 100. So the width of our board, basically, change of our puzzle, rfloat. All right, now we have a list of random offsets that has the same length as our positions themselves. So we can just say list.map2, which maps over two lists with a function to basically, and lets us specify a function how to marry an element of each of these lists into a new object or value. So let's say add offset, and then we have random offsets, add offsets, random offsets. And since we are using the pipe operator here in the beginning, that means whatever all this calculated before is passed in as the last argument into this last function. So that means our add offset function takes an element of each of those two lists, offset. So we have a tile pos, and the first list are the random offsets. So we have an rx and an ry here. And now I'm just thinking, let's just add this for now. We take tile pos and we update the position attribute. That looks brilliant. We reuse the add function to add two vectors. We take the current position and we create a new vector made out of these two random values. So if I refresh, woohoo! We have a very shuffled puzzle. That is great. I just went through and formatted the source code once, which I didn't like to do because I know that it messed up all my carefully crafted lines. But anyway, I'll go through the end and try to optimize it. Let's just make our view frame here twice as big. So now we have the nice shuffled puzzle. So, okay, now I want to be able to pick up the puzzle pieces, and I think given how much time I've already spent, 1.5 hours. Yeah, I just want to be able to pick up and set down pieces, and then I will see if I can squeeze that into 100 lines, and shall be proud if I manage to do so. Okay. So the way I would work on picking up puzzle pieces is basically I will register an on-click event on a piece, and then I will take that one out of the list of positions and to mark it as the tile being moved. And then after I've done that, I will listen to the mouse move event to eventually update the position of this moved piece. So I first going to my init function and just say the piece that's currently being moved. Oh, init is nothing. So we have our positions and we have picked is nothing. Fair enough. That should still change nothing exactly. And now if I go onto our image, I want to say on click exactly. Pick call row. And now I should get a compile error that tells me I'm not dealing with, no, actually it tells me first I don't have a pick variant, which makes a lot of sense. So let's go to our message type and rename this to pick int. And I actually do not get a compile error anyway because I'm not dealing with these messages yet at all. So if my message is yes, I have no clue what this does here, but I don't want it. Then I want to say picked is picked and positions. I don't know what that is. It's not what I want. Or actually I just do this. Picked equals picked and positions equals positions. And then I'm just going to calculate these in the let block here. So basically picked is all the positions from model positions that have these coordinates. So let's say list.filter has coords call row and has coords. Well, actually we don't need to pass in these because we can just use them as a closure style here. Blah 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 blah. Ah yeah, pos is correct. So we can just say the picked piece exactly is the one that has the coordinates, and positions is the inverted. Wonderful. So that means if I click on a puzzle piece now, it should basically, this is Haskell notation, this is ARM notation, and picked, filter. Ah yeah, this is a list, but we only want one element, so we have to call head. And I said I don't want to qualify list functions, so I'm just going to remove that as well. And then can I import it from list 3? Wonderful. Save, refresh, filter. I thought I imported it. List, I did not. I don't know why. Refresh, and now if I click a piece, boop, it vanishes because I'm taking it out of the list of positions. So of course I have to add it again in when I'm viewing it. So we are going to put it in here maybe. Let's call it view picked of picked, and we create a function view picked case p. If there's nothing picked, then we're not going to render a div, but actually an empty text node. Text from SVG, sure. I think I still have to qualify it anyway because there's already one imported. And if we have a position, then we can just say view image pause, I believe. And now maybe it flickers, but basically there should be no change when I click it. Yeah, well, there's a little change because now, actually I should add it at the end of the list so that it's always on top. Or we can just make that return a list that is much smaller, because then I can actually just return an empty array here, and here we say this. And now of course concatenation doesn't work so great anymore. Maybe I can do this. That works, and now it really doesn't change. Oh no, it's still vanishing. Because I'm clicking again and then some weird shit happens. But anyway, now what I want to do is listen for mouse move events. And this is part of the HTML, the browser package in Elm, I think. So we don't have to add another dependency, but we have to slightly change which the application type. We're not the sandbox anymore, because in the sandbox we cannot listen to subscriptions. So to be able to listen to subscriptions, we have to change from the sandbox to have the sandbox in here as well. Application, I don't know, sandbox probably got with the way up. Yeah, so here you see there's no mention of subscriptions, but if we change to element, then we can actually listen to subscriptions, and we have to deal with commands and return as well. And that's the main reason I believe there is a sandbox, because if you have a pure application where you don't have commands and subscriptions, then you just can get away with an application that doesn't care about them at all. But we do care. We want to change this for element, and to not go overboard, we just say subscriptions and just say currently we have no subscriptions, just to make it compile again, because we compare here the signature of the init function and the update function now contains the commands as a part of the return value as well, so we have to adjust those. So I just want to make it compile again before I start making functional changes. So init takes also values that we receive from the JavaScript world. So this would be our timestamp, for example, to generate actual random numbers in the future. So I could say timestamp, and I think I can cheat a bit, getting around to writing a signature function signature. Well, let's not. As I said, I don't want to do too many things at a time. So let's respect that initial thought. And an update, we now have to return a tuple with a command. We don't want to issue any commands, so we just return command none. And if we refresh, first argument is not what I expect. Ah, yeah, because the init function also has to return a command. Or can return a command. So we're going to do a tuple here and also return command dot none. And now when we refresh, now this is the only signature that Elm forces, type signature that Elm forces us to write, because it doesn't know what type of value it can receive from the JavaScript world. So we want to tell it that. And we can tell it by typing. We don't have to type the init, it doesn't matter really. I think they basically have the same signature. Let's type the main function. Add invert. And actually I will not even look at it. I just replace the A here with the union type, so void or none or whatever you want to call it. And the rest I just leave B. But it's still not happy. Picked, pause, picked does not have a position attribute. Call int. Oh no, positions. It's unhappy about positions. Why are you unhappy? Call row. So basically this is the definition of a tile, I believe. So maybe we treat ourselves to one more type alias to just be able to write down our expectations a bit more precisely. Type alias tile is this thing. It has a row and col and a vec. Or maybe I just replace list. Actually, we don't need that. We can just say position is a vec. And pick call int sure. All right. And what did I do to picked? Picked should be the same as the position. Positions, that's not correct. Position, this is also call int and row int. And then this one also has a position vector. There we go. All right, so now we have done nothing. It's called a refactoring. So we have just changed the type of our application, but now we can actually listen to subscriptions. So I'm going to create a top level function that I also call subscription. Whoops. Subscript. Yes, thank you, Codium. Subscriptions, boom. Exactly, takes our application model and returns a subscription. And so if we don't have something picked, then basically nothing moves and we don't want to listen to any events. So case picked, we can just deconstruct picked here directly from our model. Case picked of nothing. Then sub none, obviously. And if we have just something, for now, I'm also going to, oh no, let's do now we come to use our mouse over mouse move on mouse move on mouse move. Import from browser events, exactly. And so this is a bit interesting. What is a decoder? Decoder is basically a JSON decoder, because when we get the on mouse move event, we get the whole browser event. We can look this up. On mouse move. Crash course, what? Mouse move event, that sounds good. And so this event has all these properties, and the one that I think I'm interested in is client X. Relative. Oh yeah, actually no. Actually, oh, this is much better. I want movement X. The X coordinate of the relative to the last mouse move event. That's super neat. Let's take that. So basically, we want a decoder that takes out these two values and creates a message for my application from that. To be able to use decoders, I have to add another first-party dependency, install JSON. Yes. Reactor. And now I can say my decoder mouse. Oh yeah, let's just call it move decoder, and the decoder should return a message. That's the meaning of the first argument. Type argument here is like we have to create, and message should be really a type or a constructor, a variant of the message type of my application. So that doesn't exist yet. Let's go to my message type declaration, moved, and I want to receive, what do I want to receive? Basically these two values. I guess they're floats, I'm not sure. I will decode them, even if they're ints, I will just decode them as floats because that saves me from one conversion. So I'm going to say, I'm going to import JSON.decode, and I'm just going to import it as D again to be able to write a few things a bit more succinctly. So I'm going to D.map2 because the value that I'm constructing takes two values. Moved. And now I have to tell this decoder, this map2, how to get these two fields. And this is close but wrong. What Codium proposes here, what did I say? Movement X and movement Y. Movement X. And I have the feeling now it might know better what to do here. Exactly. Alright, and now I can say mouse move takes a decoder, move decode. Does this compile? It does not, because I'm not dealing with my new message in my update function yet. Let's jump to my update function. Let's import this here, moved X, Y. And for now, I'm just going to do nothing. I just want to confirm that I'm actually receiving these coordinates. I'm going to do a little debug.log xy as label, and then I'm just tossing in this decoded tuple here. Refreshing. Wonderful. Let's bring up the console. And if I pick one up now, woohoo, I get a bunch of coordinates. That is pretty sweet. Don't want to overdo it, flood my logs here. So now the only thing that's left to do is update the current the puzzle piece with the delta that I have here. Let's maybe call it dx and dy. So of course I have not control how I issued this message, so we are not guaranteed to have a picked piece here, so I'd have to do a little pattern matching. Exactly, if this is nothing, then we're really just, whoops, doing nothing. And if I have just pause, then I'm updating my model. I'm updating the picked field, and it's continues to be adjust, and I'm going to update the pause field, and this looks exactly like what I want. So if I have a picked piece, then I'm taking the delta and I'm adding it to the position of the currently picked piece. I'm very curious. Sounds too good to be true, but woo, it works. Now I just have to be able to drop it again. So first of all, I should deactivate the pick if I'm currently picking something, because I think that's what makes it disappear twice. I don't know. No, maybe let's try to drop it first. So to drop it, I basically want to listen on an on-click event of the whole thing. So I'm just wrapping this into another diff, because I don't know if I can do actually on-click on the S3G itself. And I'm not into experiments given the time. So I'll just say on-click, on-clock, on-click, drop. And create the missing union constructor in our message type. Exactly. So now we have 3 events that can happen. Either I pick something, I moved it, or I dropped it. And of course we have to update our update function to also deal with the drop case. So in this case, very, very primitive case, model picked off. Yeah, exactly. Nothing, and model picked is nothing, but we have to prepend or append the picked puzzle again to our positions list. Positions equals exactly. So let's refresh. Boom. Now nothing works, because I think all my on clicks are caught by the on click handler here. So let's say how do I do this? Maybe I only want to register the on-click handler if there's actually something picked. Map picked. A function. I don't care. Picked, exactly. So this doesn't work, because now we have still a maybe, I believe. Exactly. And so we can use maybe dot with default and no attributes, and then we pipe in the rest, and now it works again. So now I can pick up pieces again. Brilliant. And can I drop them as well? Boop, I can drop them as well. So yes, basically this is how far I wanted to get. I can puzzle. I have very uniform puzzle pieces, but I think I've made my point. The question is, can I get to 100 lines of code? So yeah, I'll spend another 10 minutes maybe to just try to squeeze it. But anyway, that's the least serious part of this journey, is always getting to it to below 100 lines. But it's a kind of a nice meditation to do it. So let's see where we're at. Basically, I'm just going to format it again with the Elm formatter, which is very spacious. Elm developers, you see, like, even if there's only an empty pair of braces on the line, even if I bring it back to this line and format again, it's like it will always format it in the same very wide space affine way. So let's see where we are. I'm just going to bring up a second console here. CD puzzle, C-log, that's the program that most people use to run these kinds of analysis. So we are at 212 lines of code. Nice. It's still, I always check that it's still compiling, and as long as it does, I'm pretty certain it's also doing the right thing. And then I don't have to really delete empty lines, because those are not counted by C-log anyways. Don't know here, 86 blank lines, so those are not included in the final number, or the number that you cannot see actually. So maybe I do this the other way around. Let's say clock source main here, and we run Elm reactor here, and now yes, that's better. We see the actual number of lines up there. That's why I'm going to rerun the command. I can also just empty this one out for the dramatic effect. Nice. All right. As I said, I was already very defensive on type annotations. I think I have barely any. Like let's do a little regex search here. So we want to have the beginning of the line, then we want to have some identifier A to Z, then we want to have at least a few of those, a space and a colon. So now you see, like, that's one not, and yes, if I press next, there's no other match. So I already didn't write any type annotations that I can rid of, which is a pity, because that would have saved me some lines, I guess. But let's start here. So let's do this. And then in my case expressions, that's always an easy way to save lines. So I'm going to inline those. Those is also fit. This decoder fits easily on one line. Even I would argue I could even just move it in line with the actual decoder here, with the actual mouse move function. Okay, maybe I give it to it like this. At least I want to make sure that at least it doesn't run out of my screen, with the only exception being the signature of the main, because I don't care. I just have to do it, so I will not care about this. And it's inferred anyway. I didn't write it, I just let it infer. And then we have a lot of these small functions here, which are also nice to inline. And this one, I said I didn't want to let it run out of the screen, so to be fair, I have to do it like this. Does it still compile? Boom, still compiles. Love it. Let's bring this on one line, and the closing bracket and the command none and the closing bracket can all go on one line. That's the init function. Then these three variants of our message type can go on one line. That's nice. Let's bring those branches always on the same line. And again, a lot of where's the comma? Let's do one line break here, but bring those on one line. The same here. F comma, boom. And then we have a lot of things, simple expressions or little functions that can be just on one line. And like, I would argue to some degree this is easier to read, like especially if the spacious indentation leads to like a function or a branch exceeding one page, then it's sometimes more readable. And like you can go as far, of course, to say like, oh, I want to line up the equal signs. But this is now comes down then to really individual taste. And I agree with the general notion that having one format for all worldwide Elm files makes them easier to understand. But again, for the sake of this experiment, I'm just squeezing out everything that I can. I think, well, let's keep the alias. Although I don't know, I can probably just delete it and not be bothered about it. Let's save and refresh. Now I am mentioning the vec in too many places, so I'm going to keep, yeah, on our constructors of the sum types here. So I'm just going to stick with this. Let's bring this where it belongs. It's closer to the type itself. So can we inline something here? Sure, we can say like, no, let's at least inline the else. And arguably this is ugly, but from where I'm starting, I have the feeling I have to make use of every single one of those. Let's maybe break it here. Transpose is also one-liner. Bezier points, well, that's, I don't know if they can they all go on one line? No, it's how many? I think it is, well, let's do 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Wonderful. This we can break down into 2 lines. This can go on 1 line. This is another super simple one, same as this one. And like, of course, in a production, in a real life application, the vector type makes an excellent candidate to be a proper module and to have all the functions there, so that you have one file that deals out with all the vector operations. And this would probably, well, there's probably some duplication and imports happening if I would do this right away. So it takes away from my goal to actually stay below those 100 lines. So I'm not going to do it just yet. Here, those are all one-liners. Except for this one. Sure. Then we have our segments. That is also just one sum type that can stay on one line. And then we have a bunch of opportunity to save space here in this case statement. And here, sure, I think this can also go on one line. Wonderful. More savings. And then here, that's a bit unfortunate because that's too long. But we can save it again by wrapping the closing bracket around. And we have another one-liner here. All right. Another one-liner here. This can also go into one line. This is also one line. And then we can just, all these attributes, we can just compress a bit. Empty bracket pair. This is already inlined. All right. So the big question, I took all the easy optimizations. Let's say, we'll see where we're at. 138 lines. So yeah, as I said, as I feared in the beginning, I think it will be hard to squeeze out 80 third lines without making this completely unreadable. Probably we can squeeze out. No, we can import. No, then I get an import for the maybe that I don't want. So of course I can start now renaming functions to make them shorter. Can I rename this? Actually, I didn't check if it still compiles. or if I broke it. Bam, no, it still compiles. That's still working. Yeah, I don't know. As I said, like I can now really push it, I guess, by being like, oh, this goes here, and then I'm wrapping this around, and then I can bring this over, and I'm always saving on the equal sign. I think you can even have the in keyword on the same line, so I can save here a few lines. Okay, one last try to make this work. This can be inlined, and then I can do also tricks using destructuring to actually make the assignments on one row here, constructing these into a tuple and then deconstructing them right away. Bam. Again, bringing the in on the same line. Then this is bottom left. Is it still compiling? Yes, it's still compiling. What else can we do? We bring the case up here. Bring the path up here. Yeah, there's a bunch of things, of course. But as I said, like I don't want to harm the readability too much. So we can do the wrapping, I don't know. Here. Does it still compile? Yes, it still compiles. We can bring up a line, save a line here. Can save a line here. But yeah, like readability is getting worse and worse as I make these compromises, I feel. But I don't know, I just want to give it one more squeeze. Yeah, sure. No, that's just nasty. I can't do it. I cannot bring myself to do it. This can for sure be inlined. And of course, like again, save it, just see if it's still compiling. Oh, no, I already fucked it up. This one? No, further back. Further back. Okay, what did I do here? I don't know. Sure. And we can also do things like we can already deconstruct positions here, positions, and then we can assign an alias. So this way we can continue referring to the model as model, and then we can say like, oh, this is just positions, and then I can maybe inline this, and I can also just cheat and say like, oh, I'm only indenting by 2 spaces, and then this still works. Saving, refreshing, still compiles. Okay, now I can do this one optimization I want to do here. What? Oh, why didn't it give me the error before? I guess mReactor was slower than I refreshed. What is it complaining about? 6446. Well, isn't that a coincidence? And we're at 64 positions. Let's just give this an underscore, and then we can remove all the positions here. This becomes positions underscore. Does it change anything? Not really. Okay, last stretch here, go further up. Now this one, yes. And then I said I want to rename this just to randoms. That doesn't actually do anything. Let's keep that. Here we have a bunch of things. I don't know if there's a power operation that takes less core pow or square. There must be something. Clamp, apps, negate, remender. No, I don't know. Something. I thought there's something more concise to do the square, but apparently I'm too blind to find it. Well, we can replace this. Whoops. Can inline this expression twice. But I'm not gaining anything. No, that's stupid. Oh no, I already have that next line there, so I could actually break this onto the next line. Does this still compile? Yes, and now we can just say r.float 0, 100. Damn, again. Then I'm saving one more line. I'm so curious. I want to inline this in here. Okay. 115. Oh man, it's painful how close I am, but anything. I still will call this a win. Pretty happy with this. I hope you enjoyed it a bit. As I said, I will probably not release another video in the next few weeks, or only if I find some time when my little one is sleeping. But yeah, 2.5 hour chunk in the day is pretty big investment currently these days. So yeah, thanks for tagging along. If you want to check out the first video where I also show you how to set up an application like this to run on Google Pages, GitHub Pages, check out my other video. But yeah, thanks for stopping by and hopefully see you soon. Bye bye.